from the today's class. So in the today's class we have discussed about the data structures. So data structure is the way of organizing, storing and managing the data in a memory location. So in that first we have discussed about the array. So array is a contiguous memory where similar kind of data are stored. So first how an array looks you can see. So first we can draw one box. So let us assume that I'm going to declare an array of size 3. So here 3 blocks of continuous memory will be allocated. So let us assume that starting memory location is 5. So I'm assuming that the integer size is 4 because the integer size depends on the compiler. So it can be 2 byte or 4 byte. So it's the size of the integer depends upon the compiler. So the next memory location is 504 and then the 508 here. So the declaration would be like int, so it would be int a of 3. So here the variable a points to the first address of the location. So a will be pointing to the 500. So let us assume the data is 1, 3 and then 7. Okay. Now if I want to access the value and the index 1, so I will just put a of 1, print of a of 1. So this will be resolved like this. So the a will be pointing to this first location. So here the pointer arithmetic will be done. So a plus 1. So which will give 500 plus 1, which is 504 because it is a pointer arithmetic. So it would be 504 and then it will just get the data from that location. So I'll put just star, then I will get the value at that location. So it will be 3. So the advantage of an array is that we can access the element by index by O of 1. So for deleting the element in the middle and inserting the element in the middle will take O of n complexity, and the array is of fixed size. So if you declare an array of size 5 and if you are using just 3 elements, still the 5 blocks will be allocated. And if you allocated an array of 5 and if you want 7, it is somewhat hard. Yeah, the next we will see about the linked list. So linked list will contain nodes, multiple nodes. So it will contain the data and the one pointer. So each node will contain, if it is a single linked list, it will contain one data and one pointer. So the data will contain the data and the pointer will point to the next node. Okay, so here this pointer will have the address of this node. So if I assume that the node address is 500, so this pointer will have this address here 500. So this is the linked list. So in linked list the linked list size is dynamic, so which is decided while the program is running. So it's easy to it's not fixed like an array. So the advantage is it is not fixed like an array. Here the inserting and deleting complexity at the middle is O of 1, because if I want to insert an element here, so let us assume that I want to insert an element here. So so address is 600. So what I will do is I will just add an first I will create a node here. So let us assume that the data and the address of this node is 700. We want to insert the node in between 500 and 600. So just I will make this pointer to point here, and then this pointer to point here. So that's it. So inserting and deleting the element in the middle will be easier compared to it will take only O of 1 complexity compared to the array. So but in the array we can search and find the element by index in O of 1. Here the finding an element by the position will be of O of n. Yeah, the next we will see about the double pointer. So the double pointer would look like this. So it will contain one data and two pointers. So the first, there will be two pointers, one pointer pointing to the node before that and the another pointer pointing to the node after that. So for example, here this first node contains the first pointer value as null because there is no node before that. So and then data and then 2. So here the 2 is the pointer which is pointing to the next node here. So and then the next node we can see that the first pointer is pointing to 1, so which is the front pointer. So it has an node before that, so it is pointing that location and then the data and then the pointer to the next node. So likewise each node will contain the corresponding pointers and data values. So here the last node will contain the after it won't have any other node after that, so it will contain the second pointer as null. Okay. So why we need a double pointer is because, so here if you want to delete a node in the middle, delete a node in the middle, so it would be by a position. So if a node address is given and if you want to delete a node, then so double pointer is makes us easy to delete the node. So because we can look into the front node and then we can just make this address as 3 and then point to the next node and then make this address as 1. So it is easy to delete the node. So this is the use case of the double pointer. So the advantages of linked list are, here the size is not fixed. So insertion and deletion in the middle takes only O of 1 complexity. But the disadvantage is that searching an element by position will take O of n complexity. So the next we will be looking into the stack. Yeah, the next is stack. The stack follows the principle last in first out, because if you give some value at the value which is given at the last will be the first. So for example, we will use the push operation to put the value in a stack. If I put push of if I put of 10, the value 10 will be added to the stack, so it will come here. And then if I put sorry, copy this. So 10 here will be here, and then if I put push 11 and then 11 will come here, and then this would be the top, this would be the top. If I pop the value, then the output would be 11, because so it follows the last in first out principle. So the last entered value will be popped first, so the output would be 11. So the use case of stack is, so it stores the function calls. So for example, if you call a function, so the compiler must maintain a entry where the after the function finishes, where it must start the execution next. So and those and all will be maintained in the stack, and then the local variable declarations will be maintained in the, because if a function if a variable belongs to a function, it is a local variable to that function. If that function if the function gets completed, then we can destroy those variables. So those and all will be those function declare those variable declaration will be those variable declaration uses the stack data structure.